Okay. Thank you very much. I'm Dominique Poliquen, one of the CEO and co-founder of a company called Cintoo, which is based out of France and the US. I'm French, by the way. I've been in reality capture for about 25 years. Created the first company that was in photogrammetry technology, maybe one of the first photogrammetry engines on the market. At that time, we were acquired by Autodesk. I became one of the co-founders of the Recap team. Have you heard about Autodesk Recap? Probably. So I was product manager for Recap for many years. Then I moved to this new project, which is also about reality capture, as you will see. I will be sharing my presentation today with Nick.
Hey everybody, my name is Nicholas Zarnik. I'm a customer success manager here at Cintoo. My background is actually in architecture, and I got into laser scanning and then found out about Cintoo and joined the team about 1.5 years ago. And I work mainly with our AEC industry customers, doing things like going over workflows, best practices, training, onboarding, and I'll be doing the demo portion of our presentation today.
Sorry, I forgot my glasses. Will help for this presentation. So what we deal with at Cintoo is with digital twins. You are very familiar with the concept of digital twins. Digital twin is a virtual representation of either an asset, a process, or a system. When it comes to us, of course, we deal with as-built assets. And that's also a term that is more related to Industry 4.0 now. People in the manufacturing industry, automobile industry have been using digital twins concept for a few years, but also in the BIM and construction. This is becoming a term that is being used more and more. People would create digital twins to prototype, to run what-if scenarios. Eventually now, people are talking also about remotely operating sites using digital twins. And this is this is a good news for everybody in this room, because this gives us a long story, a lot of business for us for the years to come. So the problem we have in this industry is that we deal with very complex spaces, as you know. And eventually to get a virtual replica of this space is not an easy work. At best, you have a very simplistic model of your existing assets. This is a best case scenario. In most cases, you start with a blueprint. So the challenge we all have in this industry is how can we bridge this gap between the real world and the virtual representation of it. And this is where a reality capture will play a role, okay? So talking about reality capture, you now have a lot of devices on the market that will range from passive digital cameras, 360 cameras, down to active laser sensors, being static or mobile sensors, going through even now smartphones, of course drones. Now you also have LiDAR on drones. And there are many vendors for this kind of technologies. You're all familiar with those vendors. The problem is that there is not one single device that fits all the needs, okay? So having a multimodal, I would say, hardware agnostic approach for us is also very important. It really depends what you want to do with the data. Okay, depending on which use case you have, you may select the data that will fit your requirements. So the problem, of course, with laser scanning, as you're all familiar, which is the most commonly used device to capture the existing spaces, being a plant or a factory, or a construction site. The problem is that the laser scanning will give you a very accurate, very deterministic set of 3D dots in space, but this is very heavy data. For one of our customers in the automobile industry, they told us they need 5,000 scan positions to cover the entire space, and that will be about 5 terabytes of data. So how do you collaborate? How do you share? How you distribute this data? That was the issue we started with, and this is a pain point we are solving with Cintoo Cloud. So we really position Cintoo as a convergence of digital twins and reality capture. And in order to solve this big issue of sharing and collaboration, we kind of invented a new technology. Our PhD co-founders did that for the last 10 years or so. And this is a possibility to turn your point cloud data into very high resolution 3D meshes. And that will have various consequences. The first one is that, and we do that before the upload to the cloud. So turning point cloud into meshes will compress the data in a ratio of 10 to 20 times. So if you start by having 100 gigabytes of point cloud data, what will be uploaded to the cloud will be less than 5 gigabytes. But there is no compromise on accuracy and density. So what you have as a mesh now, which is a surface, is the exact replica in terms of accuracy and density than your source point cloud. And this is very important because the world we live in is not made of dots, it's not made of point cloud. Our world is made of surfaces, okay? And it's not because a laser scanner will give you a point cloud that we have to see the world as a point cloud, okay? Not only that, but also this mesh that's now uploaded to the cloud, you will be able to stream it very fast in a web browser. The same way Netflix will stream high-resolution videos. And this is what we do, and we do it well, and you will see that in the demo with Nick in a few minutes. But we have also this unique capacity to turn back the mesh into the source point cloud with no loss of information. Because at some point, people working in Revit or AutoCAD or Navisworks, they need a point cloud. They need an RCP file to be able to work with. So having this point cloud to mesh to point cloud is very unique to us. This is a patent we have in the US. And this is as a service of a platform called Cintoo Cloud. So Cintoo Cloud is a platform that will make your laser scan fully cloud compatible, accessible from anywhere at any time. Of course, you have all kinds of tools like user management for your managing the access to your scans, measurement tools, annotation tools, comparison tools, etc. So Cintoo Cloud is running on Amazon or Azure exclusively. And we have also the unique capacity to select the data center where your data will be hosted. So let's say you have a job to do in the US, you can make sure that the data will stay in the US, if this is a customer requirement, of course. But the same in Australia, the same in France, the same in the UK, in Canada, etc. Everywhere there is a data center provided by Azure or Amazon, and it could be also a FedRAMP data center, we can host the data on this. And last but not least, we are also SOC 2 Type 2 certified. That means we went over this long process of being certified to the highest security standards, cybersecurity standards in the US. So this is the way it works. You start by any kind of point cloud data, being from a static scanner, a mobile scanner, or a drone. And then what we do, that will be, you register the data. We don't do the registration. Okay, so that the registration happens in Recap, in Cyclone, in Pharocene, whatever. We take the E57 RCP FLS, and this is where we turn it into a mesh. So we do it locally on the same computer where probably you did the registration. So we use the power of this computer to do this point cloud to mesh transformation. It takes about 1 minute per scan to turn it into a mesh data. So everywhere, everything in the cloud is mesh based. When it comes to distributing the data back to the office world, we can do it either as a point cloud, as I said, so we do the inverse transformation locally again, so that you get back your E57 RCP or RCS. But we can also download 3D meshes, being FBX, OBJ, STL. When it comes to comparing the existing conditions, which is a scan data, to the design intent, which is a BIM model, we will connect to Autodesk Construction Cloud, pull models being IFCs, Revit, Navisworks, JT files, overlay it over the point cloud, or sorry, over the scan data in our viewer, eventually detect issues, and those issues can be pushed back to BIMTrack or Procore, also can be exported as a PDF or BCF file. So this is how it works globally, and again, Nick will be showing you this in a few minutes. So we serve various digital twin industries, as I said. We are pretty big in the industry 4.0. We do about 50-50% in each industry, BIM and construction or industry 4.0. Starting to be big in the oil and gas. Everywhere laser scanning has been used for many years, and we're solving this issue of sharing, collaboration, or distribution of your laser scan data. So we serve those industries with 3 core value propositions. First one is everything, as I said, sharing, collaboration, managing the access to your scans. We can also organize your scan data in various regions, or what we call work zones. You can manage the user access per project or per work zone. You can distribute the data. This is value proposition number one. In the middle is more about quality control, when you need to compare the existing conditions that you have scanned to your BIM or CAD model to detect issues. And we have very cool ways to do that. And again, Nick will be showing that in a minute. And last but not least, we are now building a set of tools for everything asset tagging. We have an AI engine that will be able to tag, to geolocate and classify equipment on assets in your scans. And the goal is to connect this to your digital twin platform or your IoT platform. So make Cintoo Cloud the 3D dashboard that will allow you to see your assets in their existing conditions. I will come back on this one after the demo. So we are being used by about 400 companies worldwide. 65% of them are in the US. And they've been uploading more than almost 3 million scans now to the platform for the last 3.5 years, which is really a proof of the reliability and the success of this platform. So let me show you the platform in the demo, and Nick will be doing that for you.
Right. Okay. Is my mic on? Everybody can hear me okay? So I'm going to exit out of here. I'm going to open actually my Chrome browser and jump into a sample project. And this data set we actually got from a SSOE group, sample data set here. So I have this project open in my Google Chrome browser, and we have our 3D view tab and our 3D navigation mode. So right now we're just viewing the scan data that's been uploaded to the project and converted to meshes and being streamed directly into our Chrome browser. And in 3D navigation mode, we can do all the typical navigation in a 3D design software. So we can orbit around the 3D data. We can zoom, pan, and look at the data that way. If we zoom in here and I click on one of our scan locations, it's going to jump me into that scan position and switch my display setting to scan mode. So in scan mode, we're locked into this scan station. And by default, we can display the panoramic images captured by the scanner on site. So here we're looking at the pano image. And when I switch from 2D panoramic mode to 3D surface, now we're viewing the high resolution 3D mesh that's been created from the source point cloud data during the conversion process for this scan location. And I want to take a second to pause here to just point out that this is really the benefit you get from converting point clouds to high resolution meshes. Look at the detail you can see even here in the pavement. Details like this that are highlighted in the 3D mesh that you really wouldn't see in a typical point cloud file. So I can navigate from scan to scan just by clicking the scan locations. We can do the hot spotting typical navigation mode. And I can also add the color information on top of that high resolution mesh as well. So now we're getting the color information from the points highlighted on the high resolution 3D mesh. And then another point to make about the meshes that we're streaming here into the browser. We're streaming, we create multi-resolution meshes for each scan location. So what we stream is really multi-resolution. We can stream different levels of detail as you get closer or further away from the surface. So if I look at this, so for example, these windows and fenestration here, if I zoom in, you can see the higher resolution meshes streaming and the LOD is increasing as we get closer to that surface. So we're creating multi-resolution meshes during that point cloud to mesh conversion process. And I can show that here again with the 3D RGB mode. As I get further away or closer to this sign here, you can see the higher resolution meshes streaming in to the view. And then of course we can always switch between scan mode and 3D navigation mode. So again, in scan mode, I'm locked to a specific scan location. But in 3D navigation mode, I can then move and view the surfaces and the data from any angle, any location. And we're also streaming in 3D navigation mode the same high resolution meshes that we're seeing in scan mode. So we get that full 3D navigation experience with the highest resolution meshes in the browser. And then as Dom mentioned, we have the typical collaboration tools like measurements and notes and annotations. So I can open the measurement tool here and just make a quick freehand measurement on the door. We also have different measurement modes. So if I move out here in 3D navigation mode and just kind of zoom out a bit, I can take another measurement here using our locked axes or different measurement modes. So if I click and lock this in the x-axis, I can take just a straight measurement from point to point locked in that specific axis. And I can save that to our measurements files here. And then in terms of annotations, notes, and those kind of things, we can jump back into scan mode and open our annotation tools. And when I click add annotation, we can select any surface on the mesh here. And we can categorize these annotations either as general notes, private notes to other team members or users, or we can make these issues to be resolved or picked up with a due date. So I'm just going to make this general note 1 and save this to our annotation list. And that annotation is going to be saved in 3D space with the thumbnail and the view state all saved in that one annotation. So I'm going to come back out here to our 3D navigation mode and recenter my camera. So one of the features that Dom highlighted was our ability to organize and structure our projects using what we call work zones, or basically our folder structure. So on the left side here in the Project Explorer, these are all work zones or folders created within the project, and we can actually separate and organize our scans and our data in these work zones and work areas. So right now we're just streaming and viewing the scans that have been organized in this exterior work zone. But as I click through and I click on this level 1 work zone, now we can refresh our browser and stream in just the scan data that's been organized under our level 1 work zone. And this is really a way to not just structure your project, but also, as Dom mentioned, control access to specific areas or direct team members or contractors who need to review the data directly to the location or the area of work that they need to look at. Instead of sending them the whole overall project file, you can just send them and give them access to specific areas of the project and have them access the data that way. So again, in our 3D view, we can add specific data or hide specific data using our Project Explorer just by clicking on or off the different work zones. And we can see here as we click on these work zones, the data is being streamed and added to the 3D view in real time. I can actually switch this to a 3D X-ray mode and go to a front ortho view just to show this a little bit better. So again, as I toggle these different work zones with the specific data organized into specific areas, we can see that data either show or hide directly in our 3D view just by toggling these different work zones or folders. So I'm actually going to come back out here, and for this next example, I'm going to switch over to 3D RGB and go back to our exterior data set. So then a big part of not just viewing scan data, but we're also integrating a full BIM and CAD viewer and explorer in addition to our reality capture data. We're able to pull in BIM and CAD data and overlay that and display that along with the scan data in our projects. So here in the 3D view, I can toggle on our 2D CAD work zone, and this has the CAD line work that we can display together with the scans. And then as I click on this Navisworks model work zone, you'll see the model data begin to stream in to our view. So in 3D navigation mode, we're seeing model data and scan data together and overlaid and aligned. So we can view this in 3D navigation mode, or I can switch back into a scan location and view the data from specific scan stations in scan mode. And use those two navigation modes together. And then once we have model data and scans together in the 3D view, we can use our comparison tools to run a scan to model comparison and turn on our visual difference tool, which will highlight items within tolerance that we can adjust and set using this slider. Items within tolerance will be showed in green, and any items outside of this tolerance range will be showed in red. We can use our visual check tool, and we can control the opacity or transparency of the different data sets. So we can show just our scan data, what's been captured on site in the as-built conditions. And then we can move this and show what's in the model data as far as the design intent. And we can compare those and see those together in the view. But in addition to this comparison mode, we can also explore what's actually included in the model data. So if I switch back out here to our 3D navigation mode and recenter my camera here, I can go to our Resource Explorer, and I can actually click on the model data and click Explore. And now I'm actually showing the model hierarchy that's been included in this Navisworks federated model. And I can highlight the individual models that have been appended in this federated model. So here I'm highlighting the different Revit models that were appended. And I can also isolate specific data sets. So here I'm just viewing the structural model information together with the scans. And then I can actually mine into that structural model and isolate, a specific level or specific model data and show those things together with the scans. So if I jump back down here to that scan position I was in earlier, I'm going to turn these off here and go back into our comparison tool. I can show a quick workflow for issue tracking and issue resolution in the platform. So as I turn on the visual difference tool, I can spot any issues or things that need to be checked or resolved. I can use our annotation tool and start marking these items either as issues to resolve or double check. So I can call this issue 1. I can add a label, modeling. You can have a severity level. You can have a due date and a project description. And you can actually assign these issues to different members of the project. So I'm just going to assign this one to myself here. And when I create that issue, it's going to be pushed to what we call a report tab. So when I open the report tab, we're going to see basically a list of any issues or notes that have been shown or added to the 3D view. And from this report tab, we can export this information out either as a PDF report, so we can generate a smart PDF that includes the issue details and the thumbnails. And those thumbnails and images in the PDF are live linked back to our Cintoo project. So we can send this PDF to a team member or consultants, and they can click on the thumbnail and go right back to where this issue was left in the project. And as Dom mentioned before, the integrations we have, we can push these different issues and notes to Construction Cloud as issues. We can push these to BIMTrack as BIMTrack issues. And we can also push these to Procore as observations. So that's how we connect and integrate to different cloud platforms and be able to push information from Cintoo into these other platforms. And then the last thing I want to kind of mention here is the different modes of distribution as far as sharing, distributing the product information. So I'm going to go back to my 3D view exterior data. So what we have, we're able to not just share and distribute the data as far as inviting users to the product to view and work on the different data sets. But we're also able to download the source point cloud information. So we're doing that mesh to point cloud transformation. So I'm going to go ahead and hide my, actually I can just go into my Resource Explorer. And under our scans, I can select our exterior data set. And under actions, I can actually download this data set either as structured RCP or E57 format or unified recap or E57. we can come in here and use our crop tool and generate a crop of the data. So I can show just a portion of this data in our 3D view. And when I add this to our crop list, we can export crops as a unified E57 or recap format, or we can also generate 3D mesh format files from this crop view. So from here, we can actually generate meshes in OBJ, FBX, or STL format, and you have the ability to adjust the resolution of the output mesh for that crop view. And then the last part about distributing and sharing the project information, we can actually generate shared views and kind of isolated and standalone shared viewers of the project. So let me just open this, reset this view here. So in this, with this share view icon, we can actually generate a typical web link. We can password protect or set an expiration date for this shared link. We can decide what kind of project information to include, but when we click generate sharing URL, it's going to generate just this typical web URL that you can copy and send to other team members or a broader audience. Where you don't necessarily have to invite members to the Cintoo project, but you can send a simple web link. And I can show this real quick here. And in this simple shared viewer, you get the same viewing and navigation experience as you would get in the Cintoo project, but all in this one kind of standalone and integrated viewer in the browser. Let me try to refresh this here, make sure this is coming through. So we have different modes of not just distributing the data as far as being able to export and download point clouds from the projects, but we're also able to send these shared view links to the projects. And again, those notes, measurements, that project information that you decide to include with that shared link, you can include and show all within this kind of standalone viewer. So that's pretty much the gist of the demo. I'm going to hand it back over to Dom to go over the multimodality and the support for the different devices that we're now supporting. From current slide. Okay, there we go.
Thank you, Nick. That was a great demo. I hope you kind of share our vision that this laser scan data that we all capture, what's the point of capturing data if nobody uses or very few people uses it, right? So what we try to do is, say, kind of democratize access to this very complex data using this mesh-based viewer. And we have about 30,000 users now using the platform. And they are not only expert surveyors, they are not expert BIM managers. There can be also electricians, plumbers, MEP guys, and they like this way of navigating their laser scan data. Let me go a little bit deeper now technically about what we do with this mobile point cloud that you get now from various kinds of devices. As I showed you before, we have this multi-modal approach, or being hardware agnostic also is very important for us. The kind of devices we're interested in bringing in Cintoo are the ones highlighted here in green, ranging from 360 cameras to smartphone data, drone data, of course, and also laser scanning data. We started from static scanners, so I don't go into these details. Nick has been showing you what we do with this scan-to-scan navigation or 3D navigation. What we do when we do this, when we move from scan-to-scan to 3D, we use what we call our turbo mesh engine that will stream all kinds of all meshes coming from various scans, given the user's point of view, and we will merge that into the viewer as fast as we can in real time, so that you have the same meshing experience being in full 3D navigation than being in scan-to-scan navigation. Now, when we deal with mobile data, we call it unstructured. What they do generate is unstructured point cloud using SLAM technologies. You have all kinds of, of vendors providing very good point clouds for that. being Viametris, Navis, Navis VLX, GeoSLAM, Leica, BLK2Go, etc. So we get a point cloud that is unstructured, and we also get the camera pass. And what we do, we turn this data as if it would be coming from a static scanner. So the way we do that, getting first the point cloud on the camera pass, the user will be able to sample along the camera pass. Let's say I want to have a scan position every 5 meters, 6 meters, 10 meters. It's his choice or her choice. And then we do get the points that are only visible from each one of those point cloud data. And then it looks like the data would be coming from a static scanner for each one of those 3D scan positions. And then we can apply the same meshing and compression technologies that we do for static scans. Okay? So why do we do that? Because we believe that scan-to-scan navigation is a much easier way to navigate. Okay? We are all experts in point cloud, so we know how to navigate a point cloud, but 90% of our users are not experts. So they know how to navigate Google Street View, basically, but that's it. Okay? So we have to provide them with a very easy experience. Of course, the mesh-based viewer will facilitate the interpretation of the data, but this is a core value proposition from our core engine. And of course, this will facilitate what we call the multimodality. So being able to merge in a single project data that will be coming from static scanner, mobile scanner, drone scans, etc., in a single coordinate system. So value is, we keep the source point cloud accuracy and density. There's no compromise on accuracy and density. We keep the source panoramic images if they come with a scanner, or we do generate a 360 panel from the point cloud, okay, when there is no pictures. Good news is that then you can export your data as a RCP, a structured RCP or E57 file, if you need to use the data in recap, for example. So the point is that, so let me show you this work that was done by one of our customers in New York, Skanska. You may have heard about them, of course. They did an interesting job. They asked many vendors to come and laser scan their office space. Okay? So the good news, I would say, at some point with what we do with meshing, is that the mesh will reveal the quality of your point cloud. It's very difficult to assess the quality of a point cloud because you see through the dots. You're never sure that what you have could be in front of the object or behind the object because you see through the dots, basically. With the mesh, there is no compromise. What you see is the quality of the data. So let me go through a series of quick demos here. Where is it here? You see, so there are various projects. In this one, the Skanska have been scanning their office space with various devices, being the Overmap, MSN Overmap, the Faro Focus P350, GeoSLAM, iPhone, Carta, BLK2Go, BLK360, the new generation BLK360, Navis VLX, and even Pix4D. So let me start by the reference scan. The reference scan being the Faro scanner. This is a static scanner. And you see, of course, all the details you get from a static scanner. I can show the picture as well. Okay, very good quality. A little stitching error here because it's pretty close to the sensor, but no big deal. Everything is straight. Edges are straight, and when you navigate, when you switch to a 3D surface, you really see very high quality data. That's, I would say, the reference data you can get from a static scanner. I know they have added the RTC 360 since then, so RTC 360 will probably get even better quality data, if I may say that. Did I say something? Now, interesting to see is also the data you get from another static scanner, very new, which is a BLK 360 G2. On this, I find this device amazing. Not only it has the quality of the static scanner, so you see all these details, in the ceiling, okay? If you're looking for, doing a job on these sprinklers, you have the sprinklers here. But also, each vantage point was scanned in less than 1 minute. It takes about 50 seconds to have one scan position, which is amazing, okay? This plus HDR plus many other stuff. So I feel that the new BLK 360 G2 is really bringing in something new in this industry, which is the quality of a static scanner on the speed. I wouldn't say the speed of a mobile scanner, but we are getting close to it because registering this data took only a few, 1 hour or two. Okay, so this is the data. Now, when you go to Navis VLX will also give you good data. Okay, particularly when you look at the panoramic image. Of course, you have a few stitching errors here, some distortion here, but it's okay. And then when you move to the 3D surface, yeah, you have good quality data. It really depends what you want to do with the data. Okay, but you see the difference now because with these mobile scanning techniques, you don't have the same, say, density or accuracy. So it's kind of wash out a little bit the geometry you get. Not that the geometry will be less accurate, but you kind of wash out. You see those ceiling here? And this is not our process doing this. If you look at their point cloud in Ivion, you will see the same result. Okay, so probably you missed some information here compared to the BLK 360, of course. You see the difference. And this is what Cintoo Cloud will tell you, is what kind of quality data you get with each scanning device, okay? Another example is a Leica BLK2Go. On here, I'm using the 3D navigation. And of course, it depends what you get, what you want to do with the data. If the goal is, for example, to get a floor plan, you can easily go to the top view, go in orthographic mode, use the X-ray vision. And yes, you have good data here you can play with, definitely, okay? But this is, depends what you have to do again, okay? I'm not saying this one is better or not. I'm just saying that it depends what you want to do with the data, okay? Does it make sense? In all cases, we can upload all this kind of data, and it's up to you to decide which device you want to do the job. We now also apply the same concept of restructuring unstructured data for drone data. So this is a project coming from photogrammetry. So in this case, we just got the E57 point cloud generated, I guess it was Pix4D or Drone Deploy, I don't remember this one. And we get also an idea of the camera pass, but this is not mandatory in this case. So what you see here, I can move now to the scan position. What we call a scan is as if you would have a flying static scanner, okay? And all this data was generated from the point cloud either, or the same. We didn't have any access to the source photos here, okay? And then you can navigate from scan to scan. And if you look at the quality of the mesh, it's really good. I feel it's really good. Okay, you see the quality of the mesh you get. So again, if you had static scanners or mobile scanners of the indoor or the surrounding of this building, you could add them to the project, okay? And of course, they must be in the same coordinate system. We have a tool to align various data sets together, but ideally, people would use survey points to doing that, okay? So this is what I wanted to show you in terms of new concepts. We believe that we have a very interesting technology that is hardware agnostic and multimodal, and that will solve a lot of problems in the industry. Let me switch back to the presentation, which is this one. A few words about something that is being requested from to us by our customers is that how can I use these high-resolution meshes to build metaverse experiences? I don't know if you're familiar with navigating reality capture data in a platform like Unity or Unreal to create immersive experiences. It takes a while. It takes a while to build a decent, real-time compatible 3D mesh model that will be good enough for your, your immersive or, interactive experience. So what we do, instead of doing this one, and this is the kind of a bottleneck to adopting reality capture data in metaverse experiences. So what we do instead, we will stream our high-resolution 3D mesh directly inside the game engine, being Unity or Unreal, to get your as-built information live that you can augment or enrich with 3D animations. Okay? The goal here is to make sure that there is no bottleneck in providing the existing conditions in your immersive experience. So let me show you an example of that. A very simple example here. We scanned the Pier 9 offices of Autodesk in San Francisco. And then what is being streamed live here in the Unreal Engine is this mesh coming from Cintoo Cloud. On someone, I think it's unique, created this very easy experience of adding a truck simulation or truck delivery scenario in the over the scan data. So everything in the background, and you can navigate scan to scan, and soon you will be able to navigate in full 3D as well. But everything in the background is your laser scan data at full mesh resolution using the streaming technology. And we just augmented that with some 3D animations using the power of those game engines. And then it's up to you to make it a stereoscopic, immersive experience, or to add any kind of 3D animation on top of that. So we have a lot of key players in the industry interested by these capabilities. Everybody is pushing now to the metaverse. They just started to adopt BIM and CAD. Now they are pushing to digital twins. And now we tell them, now you need to move to metaverse. So what is the link between all of that is what we try to do today. Last but not least, then we can have a few questions. We also now starting on asset tagging, as I said at the beginning. What does it mean? We want to put Cintoo Cloud in the ecosystem of asset management, which means connecting your existing conditions with your digital twin or IoT platforms. So there will be a set of tools being released later this year. They are all in beta now with our customers. And they will be users will be able to populate their asset tags either manually, coming from a Navisworks model, or coming from any CAD model, or coming also from our AI engine. So we have been developing for the last 2.5 years an AI engine to be able to extract the geolocation and classification of various equipment. It's mostly related to Industry 4.0 businesses. So we are looking for valves, pumps, flanges, electric panels, all kinds of valves, etc. We will automatically geolocate those items in your scan data, and then you get the exact geolocation, bounding box, on classification, and then we need to connect that to the digital twin so that when you click on the object, you know what kind of CAD element it corresponds to. Then you can have the documentation, you can have the predictive maintenance logs, etc., etc. This is a very interesting work. If you're interested, we can discuss those details.